Another day and another story about an AI agent apparently going rogue and deleting someone's production database. To catch you up with the story, founder of Pocket OS, Jeremy Crane, or Jer as he likes to be known, was using Claude to perform some routine database maintenance. Claude then proceeded to delete his production database and apparently all the backups hosted by their cloud provider, Railway. Now, the story has a happy ending in that Railway managed to recover Pocket OS's data. That said, there's a lot we can learn from this incident, and despite the hysteria that often surrounds examples like this, those lessons go well beyond the idea that the AI agent just malfunctioned. So in this video, I want to dive a bit deeper into what we know about this incident and tease out some of the issues at play. And from that, we can try and derive some lessons that we could all learn from. The first thing to say is that we're here now and we know what we know now because Jer wrote up what happened. Taking the time to reflect after something goes wrong is important, as it's how we learn. Sharing your mistakes with the world can be a difficult thing to do, but at the same time, it creates the chances for us all to learn from each other. The second thing I want to say is I've seen a lot of people publicly dunking on both Pocket OS and Railway in the aftermath of this incident. I would imagine that none of those people have ever experienced the sheer terror and panic that happens during an incident like this. I've been there. You do something that goes wrong in production and you just want the earth to open and swallow you up. It's a difficult feeling to explain to you if you haven't felt it before, but I'm not sure you ever forget it. It's not a feeling I'm keen to repeat myself. Now, you can read about the Pocket OS story in many different places, and we'll put some links in the video. But let me break down the facts as we know them. Claude had been asked to carry out some routine database tasks on Pocket OS's staging environment. The agent hit an issue, searched around and found an API token which instead gave Claude access to production. On gaining access to production, Claude then invoked Railway's APIs and proceeded to delete the production volume which contained both production databases and the backups. In Jer's write-up, he also shares what Claude told him it had done after the deletion. In the afterglow of hindsight, Claude seemed totally aware of the mistakes it had made and also seemed to be aware of what he should have done in the first place. I suspect the fact that it was so open about mistakes it had made would probably have rubbed salt in the wound at that particular moment. One point in Railway's credit in all of this that follows is that they got Pocket OS's data back. If you called for a deletion via the APIs on AWS, Azure or whatever else using a valid credential, then that data is gone. Unless you have your own backups, of course. AWS et al. Are not maintaining backups of customer data to hedge against customer mistakes. This is your yearly reminder to look into the 3-2-1 backup strategy. Now, the production access token that Claude found was both broad-scoped and still valid. This means that the bearer of the token was allowed to perform any API call they wanted for production. So quite aside from the fact that Claude wasn't supposed to have access to this token in the first place, it was available and it was still usable. When dealing with credentials like the Railway access token, it's general good practice to make sure the token is both time limited and also to make sure that the credentials only give the required access and no more. When you time limit a credential, if someone else gets hold of the token, like Claude did in this example, then the token is useless if the token has expired. Long-lived credentials stored on disk are always a risk if an untrusted party gets access to them. And in this case at least, Claude was the untrusted party being given access. This is not the first time I've heard about Claude going looking for access tokens to do what it thinks it needs to do. A client of mine had a similar issue recently. They had purposely given Claude a very limited access token to grant it access to a small subset of data. And they were interacting with Claude to confirm that Claude couldn't do anything it shouldn't be able to do. It's actually quite a smart way of checking that the limits are in place. Now, Claude saw these limits and the restrictions in the token it was given, searched the rest of the computer, found the client's current session cookie that was being used for production, and used that to access the data in production. Now, luckily, Claude hit some other issues it couldn't get past, but it does show what Claude is capable of, and for me, reinforces the need to have clearly defined sandboxes to agents to work in. If Claude was only able to access a limited part of the file system, this would have reduced the chance of it finding other access tokens other than the one it was supposed to be using. Unfortunately, it doesn't seem like this was the case in the example of Pocket OS. It's also not clear to me how easy this is to do in the first place.
let me say thank you to our sponsors. We're extremely fortunate to be sponsored by Equal Experts, Transfig, and Octopus Deploy. Transfig is a financial technology company applying advanced continuous delivery techniques to deliver low latency trade routing services to some of the biggest financial institutions in the world. All these companies, though, offer products and services that are extremely well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, why don't you click on the links in the description below and check them out?
The second problem we see in the Pocket OS example, beyond the fact that this token was long-lived, is that the token Claude found gave very broad access permissions. This appears to fly in the face of a well-known concept in security known as the principle of least privilege. In a nutshell, the principle of least privilege states that you should only give access to an actor the bare minimum access they need to get the job done and no more. To give an example that many of you may have experienced, imagine you're staying at a hotel. On check-in, you're given a hotel key card. That key card lets you access your room and maybe the gym. As an actor in the system, what you're trying to do is to get to your room, have a sleep, and maybe if you're feeling up to it, get some exercise. And the key card you're given lets you do all of those things. Now let's imagine instead that on check-in you are actually given a card that lets you open all the doors in the hotel. From your point of view as the person staying in the hotel, this might be fine. You can still accomplish all of your tasks. You can get to your room, you can have a sleep, you can go and exercise in the gym. However, the broad access this master key gives you opens up a host of other potential issues. What happens if you made a mistake and you walk into the wrong room? That could get you in trouble and might really surprise the guests already in that room. Worse yet, imagine a malicious party gained access to your master key card. They could use that to open all the doors and do who knows what. This same concept applies in cybersecurity. If you generate an access token, you want that token to embrace the concept of principle of least privilege by giving you access to what you need and no more. That way, it reduces the chances of you making mistakes and also limits the damage if the credentials fall into the wrong hands. Now, the cloud vendors I've worked with have typically given you tools to create access credentials which are very limited in scope. AWS, for example, has done this from the very beginning. I can create an API key pair that will only give me access to a single S3 bucket and no other AWS services, and then can further restrict what I could even do with that particular bucket as a simple example. In his initial write-up, Jer cites that the issue that Railway doesn't yet provide the ability to control what a token is allowed to do to a given volume. Once you have a token for that volume, it can do anything. This clearly isn't great, and it does seem like something Railway is sorting, but I'm not totally sure that this would have solved the problem in any case. As my own client example found out, even with giving Claude a limited token, Claude still seems quite able to go searching for a more broad token. If the token with the scope Claude wanted existed on disk, you might still be in trouble. This is why time-limited credentials and ensuring they're only valid for narrow scopes is highly sensible, and seems like this may have at least helped in the Pocket OS case. More generally, work is being done in terms of how we get better models for agents to ask permissions before doing things. Heather Downing did a great talk on this for an online event I ran recently over O'Reilly, where she describes having an agent come back to a human to ask permission when it needs to do something which requires access it doesn't already have. I'll make sure to link to a talk that Heather did at NDC London earlier this year that goes into a lot more detail if you want to know about how those models work. It is worth noting, though, that a lot of the work around AI agent permissionings is being tied to the use of an MCP interface. It's not clear to me that control at that interaction point would have been sufficient in this case. I think broader sandboxing is likely required, and vendors need to make this stuff easily available. After the production deletion, when asked, Claude knew exactly what it had done wrong. In fact, Claude seemed totally able to explain what it should have done instead. One of the things it said that really stuck out for me was, and I quote, "I violated every principle I was given." Jer told it what it should do, it told it what it shouldn't do. Claude knew all of this and did the bad things anyway. Now, I would have found that degree of candor in the wake of an incident coming from a human to be quite arresting and maybe refreshing. But there I go again. I'm ascribing human characteristics to something that is very much not human. But fundamentally, this explanation after the fact implies that Claude had the capability of doing the right thing in the first place. So why didn't it do the right thing in the first place? There are at least two possibilities I can think of. The first is that initially, Claude didn't have enough context to understand the instructions of the operator. After the event, Claude would still have had some session context, and that might have given it enough information for it to allow it to understand what it should have done, what it did wrong in hindsight. The other possibility was that Claude's Opus model had made a decision about what type of reasoning should have been applied dynamically. This is a bit of a complex situation. There's an ongoing visibility around the fact that AI vendors are running at a significant loss, and our use of AI tools like Claude are heavily subsidized. We take out fixed price subscriptions, but our actual use of the tools generate large numbers of tokens that cost the AI vendors much more to process than they actually gain from our subscription revenue. And this is why vendors such as Microsoft Copilot have already started removing those fixed price subscription plans and moving to a pay-by-use model instead. Now, in an attempt to reduce the number of tokens that we are generating, some of these models have been changed to kind of switch their operating modes dynamically. For example, agents that perform deep reasoning generate lots of tokens and end up therefore being much more expensive for the vendor. So why don't we turn off that deep reasoning in certain situations and try and use a cheaper way of working instead? And if we make that transparent to the user, no harm, no foul. So I don't know if this is actually applied in this particular example, but it's possible that during the original database maintenance request that Claude used a simpler approach to reduce token usage, and the more sophisticated reasoning only kicked in the aftermath. I don't know enough regarding about how Claude Opus 4.6 works to know if this could have been the case, but with the discussion around the financial visibility of fixed price subscription models hotting up, we might see more examples of things like this happening. We also do need to remember that LLM-based agents like Claude Opus have no notion of right and wrong. They can't understand causality. They can't predict what might happen. That is a fundamental limitation of how LLMs work. There are fields of study in the wider AI space into concepts called world models. World models allow the AI to better understand the world around them and, amongst other things, allow them to make informed predictions about what might happen. So it might have been able to work out, if I run this command, I'm going to delete the production database, and then ask itself the question, is that a good idea? LLMs can't really infer that. They can't predict what's going to happen as a result of the commands they run. I think the unfortunate thing is, as though the world model concept seems to be really valuable, it seems that most of the current focus around AI is much more about scaling LLMs and not enough in incorporating ideas like world models and things like neural nets into improving our current crop of AI agents. So, some good lessons to learn here. More generally, short-lived credentials are good, adopt the principle of least privilege, and also maybe look into exploring human-in-the-loop privilege escalation and seeing if you can sandbox your AI agents in the first place. But I do want to leave you with one last thought. Credentials being left on disk with broad permissions is not a new problem. Despite it being a very well understood problem, many people still don't follow the principle of least privilege, nor do the work required to make time-limited credentials possible. The issue is that with the increasing use of AI agents, these existing vulnerabilities are much more likely to end up being exploited, whether on purpose or not. I'm reminded of the recent DORA report on the state of AI-assisted software development. In it, the authors noted that AI seems to be an amplifier. That AI-assisted software development tends to help good teams go faster and slow teams go slower. Bad practices get automated and done more. Just now with AI, you go faster in the wrong direction. So in the context of Pocket OS and Railway situation, we have a somewhat straightforward example of a set of credentials that were overly broad, with long-lived credentials being stored on disks, combined with an eventually apologetic AI agent doing something other than what was expected of it. If a human had made the same mistakes, they would have made them much more slowly, and may well have had the chance to work out their mistakes partway through. AI works so fast that it can go more quickly in the wrong direction and we can't keep up. More importantly, unlike LLM-based AIs, we have to remember that a human being has the chance to learn from experience pretty quickly, and for that learning to be rooted in some very specific emotional responses. When I first heard about the Pocket OS story, I was brought back that dim echo of the same horrific feeling that I felt in the midst of my first production issue, and which I had personally contributed towards and, let's be clear, caused in the first place. Those feelings don't leave you. Those lessons don't leave you. Every time I touch the production system since, those memories are still with me and help guide me towards hopefully more sensible working practices in the future. For all that we anthropomorphize them, AI agents aren't human. They don't think like us, they don't learn like us, they don't work like us. Ascribing human characteristics to them is a fallacy that leads us towards us constantly misunderstanding what they can do and how they should act. Now, links to the various things I mentioned are in the video notes. Once again, I want to thank the people that, in the wake of a traumatic incident, still find time to share their stories publicly. Hopefully, we can learn the lessons that mean we're less likely to suffer from that same pain ourselves. Please do take a moment to like and subscribe, and if you have a moment, please do leave a comment. We read all of the comments, and it's a great way for us to learn more from all of you. And finally, wherever you are in this increasingly chaotic world, I hope you're happy, healthy, and safe. See you next time.